Hi guys, in this video I'm going to explain two more factoring methods. The first one is factoring trinomial squares. Um, Before to explain factoring trinomial squares, I'm pretty sure that you can remember this case. This is a special product. If you remember, this special product over here is a binomial square, and it's because we have a binomial here that is affecting by a square. If you remember the property say that the first term, that in this case is x squared here, the first term is square, plus 2 times the first term times the second one, it is term in the middle, and finally the second term, that is y square, then y square. Okay? In the similar way, when we have a subtraction, it's exactly the same case, binomial square, but in this case, when it's minus, the only difference is that the term in the middle is going to be negative. That's it. Why? Because when we multiply 2 times the first one times the second one is negative. Then it's going to be negative over here. Okay? Then now let's analyze the case. Factor. If we have to factor this trinomial over here, this is going to be the answer. Then if you can see, it's exactly the same, but it's exactly the same process, but in the inverse. Okay, the reversing process. Okay, then this one corresponds to this method over here, and this one corresponds to the second special case, or to the second example for a binomial square. Okay, then it's exactly what we have to do. It's exactly what I'm going to explain. It's really simple. You have to be very focused. Then the first thing that I'm going to explain, guys, is how can we recognize if a trinomial is a trinomial square. Then let's analyze, let me explain it with this exercise, with this example. X squared plus 6x plus 9. Okay, then to recognize, to know if a trinomial, this trinomial in this case, is a trinomial square or is not a trinomial square, the method of the process is very, very simple. The first thing is we have to find the square root for the first term of the trinomial. Okay, obviously, let me remember that you have to organize the trinomial first in descending order. Okay, then let's start again. Square root for the first term and square root for the last term. Remember, the trinomial must be organized in descending order. Now, the square root for the first term must be exact. In this case, is x, and for the second term must be exact. In this case, is 3. And when we multiply these answers, x and 3, or x times 3, the answer is 3x. And if you can notice, 3x is exactly the half part for the term in the middle of the original trinomial. If this happens, it's because the trinomial is a trinomial square. Then in this case, obviously, we apply. Then we know that x squared plus 6x plus 9 is a trinomial square. Now, when we recognize that it's a trinomial square, then we are ready to solve. Okay? And how can we solve it? It's really, really simple. Then once we prove, or we prove that the trinomial is trinomial square, then we have to open and close one parenthesis, put the square root outside, okay, and remember where is the square roots, x and 3, then put it there, x and 3, and the sign here between x and 3 depends for the sign for the term in the middle. In this case, the term in the middle is 6x positive, then the sign here is going to be positive. That's it. Factor is ready. Now let me provide 3 more examples. Okay, to solve these examples, remember we have first to prove if the trinomial is a trinomial square. Remember, guys, first always organize in descending order. Equation number 1 or exercise number 1 obviously is not in descending order, then we have to organize first. Remember that also it's important to remember that if it's possible solve by greatest common factor before to apply the method, we have to do it. Okay, then let's organize first. X squared, obviously, minus 14x is the second one. Remember, must be organized in descending order. And finally, plus 49. Then one more time, square root for the first one, square root for the last one when the polynomial is organized. Square root is x, square root is, in this case, is 7. Now, if we multiply, x times 7 is 7x. 7x is exactly the half part for the term in the middle. 7 is the half part for 14. In this case, it's not 14, it's negative 14. Doesn't matter the sign. The sign is not important in this case. Important is the number and is the half part. Then when we're ready, then we say that this is equals to open and close to parentheses. Remember square root outside, and then put the square roots in here, x and 7, and the term in the middle depends for the term in the middle when the polynomial is organized. Be careful when the polynomial is organized. In this case it's negative, then here it's going to be negative. Be careful, don't be confused, because in this case the term in the middle of the original is positive, yes, but the trinomial is not organized. Always always important, organize the polynomial before. Now let's solve the exercise number 2. Exercise number 2 then is organized already, yes. Then it's possible to solve by greatest common factor, not, because 25 is odd and these two are even numbers, then it's not possible. Then let's prove that it's a square root, is a trinomial square. Then a square root for the first one, square root of 16 is 4, square root for x squared is x, and for the last one, square root for 25 is 5. When we multiply them, the answer is 20x, and 20x is exactly the half part for the term in the middle, that is 40. Then remember, then that means that this is equals to open and close to one parenthesis, put the square outside of the parenthesis. In other words, it's going to be a binomial square, and put the answer of the square root inside, and the sign between them depends for the term in the middle. In this case, the term in the middle is negative 40, then it's going to be negative. That's it. Last example, last exercise, one more time. Greatest common factor is not possible in this case. Then, the trinomial is organized, yes. Then let's start finding the square roots for the first one and for the last one. Square root of 4 is 2, square root for p squared is p, square root for 9 is 3, and square root for cube square is cube. When we multiply them, the square roots, the answer is 6pq. And 6pq obviously is the half part for the term in the middle, that is 12. That means that it is indeed a trinomial square, a perfect trinomial square. Then we have to open and close to one parenthesis, square root square outside, and p to p is the first square root, and the second square root is 3q, and the sign between them depends for the term in the middle, and in this case is negative. Then we have to write a negative sign. Guys, remember that always is important, check your process. How can you check your process? If you apply the special product here, your answer must be the original polynomial, or if you apply here the special product also, and here also, then in other words, how can we check if the factoring process is correct? By multiplication. In this case, multiplication of binomial square. Okay, this is the first method that I was going to explain. Now let me show you the second factoring case. The second factoring case is factoring difference of squares. In a similar way for the previous exercise, for the previous method, I'm pretty sure that you can recognize this case here. This case here is is a special product, another special product that we call the product of the sum and the difference. And it is the sum and the difference because it's a product, it's a multiplication here, obviously, and is between two terms, x and y exactly the same, and in one parenthesis they are adding, like here, and in the second parenthesis they are in a subtraction, like in here. Okay, that's the product of the sum and the difference. In that case, I explained in a previous video, in another video some time ago, that is the first term square minus the second term square, and it's always minus. Okay, then the reversing process, now let's be focusing here, the reversing process is the factor. Then if I said, hey, please factor this polynomial, x squared minus y squared, then this is going to be the answer. Let me explain how can you do it. Then first, let me explain how can you recognize difference of squares. Difference square is very simple to recognize. First must be a difference, then it's a subtraction. First, And secondly, is a difference between two expressions or numbers that is possible take the square root. Perfect, the square root. Then if we apply the square root for x squared, it's possible and it's exact, and for y squared, it's possible and it's exact. Then that means that it's a difference of square. Then let me explain this exercise. First exercise, x squared minus 4. Then x squared is possible to find the exact square root? Yes, is x. And 4 is possible to find the square root? Yes, is 2. Then remember the method, you have to open and close two parentheses and put the square roots there. X, 2, and x and 2. Very easy. And now in one parenthesis must be an addition, and in the other parenthesis must be a subtraction. That's it. Now let's apply exactly the same in the second case, in the second example. Then remember, if it's possible by greatest common factor, but in this case it's not possible, then let's apply the method square root for each of them, and the square root must be exact. Square root of 9 is 3, and the square root for 16 is 4, and for t to the fourth power is t squared. Okay, and yes, then was exact. Then remember, open and close two parentheses, put them the square root inside. Then 3 is the first one, and 4t squared is the second one. Then 3 and 4t squared. And remember, in one parenthesis is plus, in the other one is minus. Doesn't matter if you put minus in the first one and plus in the second one, is exactly the same. Now let's analyze the example number 2. Example number 3. In example number 3, just let me fix this because it was my mistake. The original exercise is 18x squared minus 50x to the 6th power. Okay, then let's analyze. If you think the square root of 18 is not exact and the square root of 20 or 50 is not exact, then we can think, this exercise is not possible solved by difference of square. But it's because we are forgetting something. We forgot that always, if it's possible, find the greatest common factor, we have to do it. And in this case, the greatest common factor for numbers is 2, and for variables is the smallest exponent. The variable with the smallest exponent, in this case, is x squared. Then 2x squared times what is 18x squared? Then obviously it's going to be 9, just 9. And 2x squared times what is going to be negative 50x to the 6th? Then it's going to be negative 25x to the 4th. Okay. Then this x squared, 2x squared is already factored. Okay, then it's part of the factoring answer. Now let's apply inside of the brackets the strategy. Then square root of the first one, square root of the second one, and they must be exact. Square root of 9 is 3, is exact, no problem. Square root of 50 or 25 is 5, and square root of x to the 4th is x squared. Then they are exact. Then obviously we have answer. Then remember that we factor from the beginning for greatest common factor 2x squared. Okay, and now open and close two parentheses and put the square roots in there. Then 3, 5x squared in the first one, and 3, 5x squared in the second one. One parenthesis, remember, one parenthesis is plus and the other parenthesis is minus. Doesn't matter which one is plus and which one is minus. That's it. Then this is the answers. Remember, guys, if you want to check your answers, then solve the special product, solve the multiplication, and the answer must be the original polynomial. Thank you, guys. That's all. Bye-bye.